So we have our smoke here, and let's maybe just organize this just a slight bit, and I'll move this over here. So this is where we generated that an attribute. Let's move these over here, and maybe all of these can become, let's see, let's grab one of these nodes and paste it here, and this can be just sources. Okay, and then this will become my smoke simulation. So this will be head smoke. This is body smoke, and this is head smoke. Okay, so let's see how we can create our particles. We will use probably the same source that we did for the smoke. Okay, so I can simply copy paste this node here. This is the head source, which, if we remember, is this node over here, which has this nice noise attribute, and we know exactly where we want our particles to spawn. So I will grab this, Control C, and let's move this over on the right over here. Okay. So here we have our node, and we can just drop this into a pub network. And let's step inside here and set up some parameters. For my pop source, I will disable guide, use emission attribute CD, scale point count by area, and let's lower this to maybe 0.01 and go to the birth tab, and let's start with a life expectancy of maybe 1, and I will do the same thing that we did earlier and copy this channel in the live variance and divide by 2. Okay, and let's preview this and see how many particles we are working with. Let's go maybe up and reset simulation. Okay, so we can see that we are quickly going towards 1,000,000 points. And for our final particle simulation, we will probably use a value of a few million, but just for our preview purposes for now, we don't need that much. So I'll just drop this value for the birth rate to 500. Let's play this now. Okay, so now we can get a good idea on how our particles will look. Let's start with our advection, and we will use a similar method to the one that we used earlier for the body. So I will drop down an advect, let's see, pop advect by volumes. And again, we will use the velocity of the smoke for the first pass of the advection, and then we will use the volume gradient for our second pass to squeeze the particles along their flames. And let's rename this to advect by vel, and we need to grab our velocity volume. So let's go up, let's go here where we cached our smoke. Okay, and I will grab this node and plug this into our advection. So let's go to pop advect by volumes and paste this over here at our SOP. Advection type will be update position. Let's see, final velocity and trace method. Okay, so if I preview this as it is, our particles are nicely being pushed by the smoke, and we are on our way. Maybe our particles are lasting a little bit too long, so let's maybe make them die off a little bit quicker. So I'll set the life to maybe 0.7. Let's see this. So this is pretty good for now. Let's maybe set up the rest of this simulation. And I will just grab this node, and holding Alt I will duplicate this node, and this will be advect by gradient. Let's go up a level and let's compute this gradient. So from this smoke simulation over here, let's drop down a volume analysis and plug this here, and form by volume analysis, it will be exactly the same as we did for our body. We will want to grab the density, and we will compute a gradient for this density. And now this density becomes a velocity volume. As we can see, it has X, Y, and Z component as well. And let's drop down another null over here, and this will become my head smoke gradient. Grab this node, let's go back to our pop simulation, and inside here we can place this inside our second advect node. So over here at the sub level, Paste this here, so now this will look at the smoke gradient, and the field name will change from velocity to density. And by default, this velocity scale of 1 will be extremely large, so I will just scale this way down to maybe 0.01. And let's preview this now. And now we can see that the particles are being squeezed together and forming these nice tendrils. This may be a little too much, but let's actually just increase the count maybe to 1000, so we can maybe see this effect more clearly. And maybe still the particles are lasting a little too much. Let's maybe scale down the life expectancy to maybe 0.45. So we really only want these particles to last a little bit. Okay, so this is much better now. Let's maybe still increase this birth rate. Let's maybe say 3000. So we want to get a better idea on how this effect will look. Now we can do the same thing with this second advection. Is we can fade in this velocity scale based on the age. So I will set use expression on, and I will want to convert my age attribute again to a float, which will be my age in frames. So then we can say that from when the particle is born, after 5 frames, fade in this velocity over 5 frames. So let's just see how this will look. So I will say float age, and this will just create a new variable for me. And again, you can name this however you want. We can name this bias or whatever, or multiplier, but I will just simply name this age. Just note that this is not the same as our @age attribute. Okay, so I will say that this age will be equal to grab our age, and if we divide it by the time increment, so at time_inc, now we will get the age in frames. So what we can do with this now is again do the same thing we did for the body, which is say that vel scale, so this parameter over here, I will multiply this with a value based on the age. So I will say fit, and in parentheses I will fit the age, and like I said, from frame number 5 to 10, this will now be 0 to 1. Okay, so now for the beginning 5 frames of any particle, this will not take place, so this node will not be affecting our look, and after 5 frames this will fade in over another 5 frames. So from 5 to 10 this will have 0 to 1. So before frame number 5, from which a particle is born, it will have a value of 0, and after 10 it will have a value of 1, which is a multiplier for this velocity scale over here. Okay, so now if I preview the result, we are allowing the particles to be advected just by the velocity, the regular velocity of our volume, and we are slowly fading them towards our new velocity from frame 5 to 10. So we maintain a natural looking shape right when they are born, and then we are slowly fading in this squeezing effect over 5 frames. Let's maybe go up at the top level and select my pop net over here, and I'll just increase the substeps to 2 over here. So this will, because the particles are moving a bit fast, it's worth increasing this to 2, just so we allow a little bit more calculations for our particles. And we can still see that there is a sort of stepping effect that occurs as the particles are being pushed by the smoke. But we will take care of that a bit later. So for now, substeps of 2 will be good. And let's go to the cache, and I will set the cache memory. I will just increase this by a factor of 10. So this will allow me to cache a little bit more particles without having to use a file cache. Okay, and I can maybe see that this smoke is slightly a little bit too detailed, and what I can do actually is over here after our file cache, so after we cache the smoke, we can blur the smoke a little bit, so we kind of smooth in the way the particles are going to be affected. So I'll just drop here a volume blur, and we just need to blur this a tiny bit. By default this is way too much. Let's turn this on, use voxel radius, and let's maybe scale this down to a radius of 0.5. Okay, so we can preview with or without. We can see that there's just a slight blur, and this will make our advection look a little bit smoother. So if I preview this, we still have a lot of interesting shapes going on, but it's just overall a little bit smoother.